What we will do is to use the rules of logarithms in order to actually either expand or combine the terms into one. In this specific problem that we have here, what we will do is to combine the terms. Combine the terms. How many terms do we have? We have 1, 2, and 3. We want to combine them. The first thing that we can see is that we have a plus. And this means that we can add this term right here with this term right here. And then we will subtract this term right here. So I will rearrange them in order to make sure that we make no mistake. And I will have the plus first and then the minus. The reason is that we do follow the PEMDAS order of operations, but we want to make sure that we first perform the addition and then the subtraction. Okay, we have two logarithms, we add them up, and this means that we are able to multiply their arguments. Before we do that though, we will consider each one of those logarithms and we will use the exponent rule in order to rearrange them with the 4, with the constant that is multiplied by the logarithm to the exponent. So I have this logarithm of x to the 4th. Here I have 2 times log, so I will push the 2 at the exponent of the argument. And here I have 1/3, so I will push the 1/3 into the exponent of this argument. Now I have a sum, so I will multiply the logarithms. So I have log of x to the 4th times x minus 1 squared minus log of x squared plus 1 to the 1/3. And since here I have a minus, this means that I can divide the arguments of the logarithms. And I have a log x to the 4th times x minus 1 squared divided by x squared plus 1 to the 1/3. Now the exponent 1/3 is nothing else than the third root, the cube root of the argument. So I can rewrite that into log of x 4th times x minus 1 squared divided by the third root of x squared plus 1. Let's look now into another logarithm. I will expand by distributing the 2 to each one of the logarithms. Right here I have the natural logarithm. 2 times 2 is 4, ln of y, the second term. 2 times negative 3 is negative 6, ln of z. The first step is to push each one of the coefficients here to the top, to the exponent of the logarithm. And I have ln x squared plus ln y to the 4th minus ln of z. The next step is to consider the sum. So always I go exponent, addition, and then subtraction. Ln of x squared times y to the 4th minus ln of z. And now I focus on the negative. This means a quotient. I will apply the quotient rule and I have x squared y to the 4th divided by z. And that's my final answer. Let's assume now that I have a logarithm and I want to expand it. So I will follow exactly the opposite process using again the rules of logarithms. I start with the log of 5 and I pay attention. The first thing that I do is the subtraction. So I have log of 5 of the numerator, that is this, minus log with base 5 of the denominator. The next thing that I do is the addition. So I have right here 3 times x squared, and this can be split into log with base 5 of 3 plus log with base 5 of x squared minus log with base 5 of y to the third. So I'm done with the addition, and the next thing that I should do is the exponents. For the first term I have no exponent, so I leave it as is. The second one I will bring the exponent down and I have 2 log with base 5 of x. And the third one, the exponent is 3, I bring it down and I have 3 log with base 5 of y. Let's look at one more problem. Again, remember, when I go from the combined form into expanded form, then I go from addition, subtraction, exponents. When I move from the expanded form to the combined form, then I go upwards, exponent, subtraction, addition. So now I go from combined to expanded because I have the combined and I want to expand it. So I'll go addition, subtraction, exponents. ln of x to the fifth. I don't have an addition here or here because I have the square root. So I go to ln of x to the fifth minus ln of square root of 2 plus y. Then I need to go to, I finish with the subtraction, so I need to go to the exponents. So I have 5 ln of x. The second one though is square root. I need to remember that square root is nothing else than one exponent, that is 1/2. So now I bring the exponent 1/2 down and I have 5 ln of x minus 1/2 ln of 2 plus y. Remember, I cannot do anything here. You can always split the ln or the logarithm further if you have a product or a quotient. If you have plus or minus inside the argument, you cannot further split it. So the final answer for this problem is 5 ln of x minus 1/2 ln of 2 plus y. Now, I want us to carefully look at each one of the problems again. I have the expanded form and I want to get the combined form. I start with addition, I move to subtraction, and then I consider the exponents. This is a mistake. I start with the exponents, then I consider the addition, And finally, I consider the subtraction. The next problem. I start with the exponents. Again, I go from expanded form to combined form. The difference here is that the 2 is multiplied by all of them. Again, I first need to distribute to bring it into the entirely expanded form. So if I go from expanded to combined, I go exponents first, addition, then subtraction. Same thing as I did here. Exponents first, addition, subtraction. While in the next problem, what I had was from the combined, I had to go and expand it. So it was the opposite process. And because it was the opposite process, the way that I worked was exactly the opposite as well. Subtraction, then addition, then exponents. And the same thing I did right here, where I had the combined form, and I went to the expanded form, and I went again, subtraction, then addition, then exponents. The difference here is that I didn't have any addition, so I skipped completely this step.